everyone! Have you encountered the sentence, math is everywhere? Well, if you did, allow us to enlighten you about what this simple three-word sentence really means. I am Darweena.
I am Karyl.
I am Aya.
I am Ocean.
And welcome to Math Daily. The pictures that we see in our environment are overflowed with patterns. The beauty and the uniqueness seen from the vivid and visible clues of nature were not made for mere admiration and to merely satisfy the completeness of the universe in which the people live. Rather, they are vital to the rules of a certain extent, controls and make up the natural processes which shape the natural communities. In fact, these plants, I don't particularly know what they are called, but they have certain dimensions which can be classified into different types. A proof that nature really has its patterns that comes with numbers. Plus, there is a reason why the clouds are shaped like that. Human mind and culture have developed a formal system of thought which resulted in the recognition, classification, and exploitation of patterns, which what we call as mathematics. The example of patterns that we often see in nature is first the six-fold symmetry of snowflakes, the pattern of stripes in tigers and zebras, the pattern of spots in leopards and hyenas, a bright circular halo, colored arcs of light, and spherical drops. Amazing, right? Well, this doesn't end here yet. Karyl has even more to tell you.
Wow, the universe is really filled with patterns. It was only recently that I realized that, Darweena. Anyway, to add up on our adventure about the nature's numbers, allow me to introduce you to Johannes Kepler, a German astronomer who wrote a book, The Six Cornered Snowflakes. In the book, it is said that snowflakes must be made by packing identical units together. He performed no experiments and only relied on his knowledge. His evidence for this is the six-fold symmetry of a snowflake, which is a natural consequence of regular packing. For example, you can get a honeycomb arrangement if you place and pack a large number of identical coins on a table. This time, I will show you the reason behind the different patterns and clues of nature. First is the nightly motion of stars, which is the result of the Earth's rotation. Waves and dunes shows how the flow of water, air, and sand is governed. Tigers' stripes and hyena spots is an attestation of the mathematical regularities on biological growth and form. Rainbows are a result of the scattering of light and indirectly tells us that raindrops are spheres. And of course, lunar halos are clues to the shapes of ice crystals. These are the different beauty that deduce the rules and regularities in mathematics. I think Aya wants to add up some more knowledge for you.
I hope our viewers aren't exhausted yet, Karyl, because this is something really worth listening for. Patterns possess utility as well as beauty. Once we have learned to recognize a background pattern, exceptions suddenly stand out. There are two types of patterns, known as fractals and chaos. Fractals are geometric wave shapes that repeat their structure on ever finer scales. An example are the clouds. Whereas chaos is a kind of apparent randomness whose origins are entirely deterministic. An example is the weather. The simplest mathematical objects are numbers, and the simplest nature's patterns are numerical. The year is 365 days long, roughly. People have 2 legs, cats have 4, insects have 6, and spiders have 8. Starfish have 5 arms, or even 10, even 11, 17, depending on the species. A very curious pattern indeed occurs in the petals of flowers. These patterns found in metals is called the Fibonacci sequence, wherein lilies have 3 petals, buttercups have 5, many delphiniums have 8, marigolds have 13, asters have 21, and so on and so forth. Each number is obtained by adding previous 2 numbers together. For example, 3 plus 5 equals 8, 5 plus 8 equals 13, and so on. That's it. I think I have to pass this camera now to Ocean.
Numerology is the easiest and consequently the most difficult method in finding patterns. Here's a case in point. Kepler found out that if you take the cube over the distance of any planet from the Sun and divide it by the square of its orbital period, you'll always get the same number. Confusing, right? Well, anyways, the significant observation in numerology are the vertical posterity, which involves the calculations of squares and cubes. This numerical pattern was one of the key steps in Isaac Newton's theory of gravity, which later on explained the puzzles and motions of stars and planets. Let's admit that nature's numbers sounds better than nature's numbers in shapes. Shapes can always be reduced numbers. Main shapes appeared to mathematicians are very simple ones. For example, circles, squares, pentagon, hexagon, and triangles, and etc. For instance, The flow of fluids provides an inexhaustible supply of nature's patterns, and also the wave-like patterns of land. There are also patterns of movements, such as humans and horses walking in a rhythmic manner, pulsation of jellyfish, flight of birds, and the wave-like movements of fish, snakes, and worms.
Everything random and formless is still a pattern for clue or evidence. The new understanding of nature's secrets gives us a better vision of the universe in which we live and of our own place in it. And that's for 5 minutes. See you again next time.